Okay, so the way I've been drawing amino acids so far isn't completely faithful to how they look inside the body. And so that's what I'll be talking about in this video. So we'll start off with something called a zwitterion. And what a zwitterion is it's a molecule that has both a positive and a negative charge. And Zwitter in German means hybrid. And so it's a hybrid between a positive ion and a negative ion, but it has a net neutral charge. And so you can imagine in the body there's a wide range of pHs, anywhere from 1 to 14. And at a pH of 1, there's a lot of hydrogen atoms present, or a lot of protons. And so any group that can be protonated will be protonated. So both the amine group and the carboxylic acid groups will be protonated, and that'll leave us with a net positive charge in our generic amino acid. I'm putting a little asterisk here, and we'll get to that in a second. At a pH of 14, there's mostly hydroxide ions, and so any group that can be deprotonated will be deprotonated, and that'll leave us with a net negative charge. So somewhere in the middle, there's a neutral point, and that is known as the isoelectric point, which is the point at which an amino acid is net neutral. And so the way we get that for a generic amino acid is we look at when both side groups get deprotonated, which for an amine group is 2 and a carboxylic acid is 9. So on average, the pi is around 5.5. Now this is true for most amino acids. Can you guess which ones it's not true for? Those would be the charged amino acids, because the charges on the R groups mess with the point at which the amino acid is neutral. So the way I like to keep this in mind, and this is a little silly, is it's dragons eat knights riding horses. Where the bad guys of this sentence are the dragons who are doing the eating. And you can imagine when you see a dragon, you like gasp, except, because it starts with a D, you dasp. And so asp is aspartic acid. For eat, I remember eating glue, and that seems to do the trick for glutamic acid. The good guys of our sentence are the knights who are riding on horses, and they're willing to risk it all. They're not willing to risk it all, because that would just be dumb, but they're willing to risk it all, where risk is lysine. R we say for R, like pirates, arginine, and then H is just histidine. And so that's just the way I remember the charged amino acids. But on average, those are going to have different isoelectric points because of their charges. And so for the negative amino acids, the pi is going to be less than 5.5, and for the positive, it's going to be greater than 5.5.